Yeah, how's it going, mate? I'm Obsidian Zenon. A while ago, I picked up this old silicon chip signal generator kit for 20 bucks. And it partially worked, but this coarse knob here was faulty, so I replaced that and kind of had to do this weird bodge job with these wires because the potentiometer doesn't actually fit once the whole thing's been assembled and soldered together. So that's a little bit of an oversight. But anyway, I did that, and there's still a problem. There's no output when I have the sine function. So I can actually show you on the oscilloscope. Just give me one sec. Alright, so this is set to 100 hertz roughly, and I'm just going to probe the output of this. And, oh, hang on, let me turn my time down. Okay, so see there's a very nice square wave, and I checked it, it's all accurate. But then if I go to sine and probe that, nothing, absolutely nothing. Doesn't matter what I do, which setting I go to. If I go to 500 kilohertz setting, that is just mains hum right there. Okay, so absolutely nothing on the output, and absolutely nothing before the amplifier output. However, if I go and probe this wire here, this jumper thing, I get a very nice sine wave, which is the correct frequency. Can I confirm that? Yes, I can. That is 100 hertz roughly. And yeah, that's a very nice DDS sine wave because this is a digital signal generator. But the fact that that's there, but there's nothing on even the input of the amplifier right at the output stage, tells me there's something wrong in this circuit. Now, I'm going to reverse engineer this circuit. For this issue, I probably don't have to, but I'm going to because it will probably be helpful later on when this thing inevitably breaks again. And you can see this has been recapped before I even bought it too. So it's not completely out of spec, but it was a bit dodgily put together. Yeah, I'll have to reverse engineer this before I do anything. So yeah. Yep, so you can see, and I'll show you the underside of this thing in a sec. It's been messed with quite a few times. Looks like it's been, wasn't properly assembled in the first place, and then it's just got fixed over and over again. It's just been pretty terrible. Don't worry, this is all unplugged, so I'm not putting myself at risk here. I did ask Silicon Chip. I emailed them, and I asked them if they'd just send me the pages of the articles June, July, maybe it's July, August 1990 that this thing was in. They did not reply to me at all, which is annoying. So that's why I'm having to reverse engineer this. Yeah, I did ask on forums and stuff too. No one seems to have anything. So yeah, this is kind of the only way for me. By the way, this circuit is actually fairly safe to work on while it's on. The only dangerous parts are this switch, which is insulated, and behind this transformer down the bottom, which is where the live and neutral connections are. Everything else, this is isolated. But I do still have to not connect my oscilloscope ground anywhere because the ground of this circuit is actually mains earth. So this BNC is actually sorted to this BNC and the others, and that terminal and this terminal. And yeah, so very dangerous if I connect my ground clip to something other than ground on here, so I just took it off. So it looks like this coarse knob has actually been replaced more than once. And I also know that because it was actually originally a newer knob than the fine knob, so it seems to have had problems many times. But you can see terrible flux job there. I didn't even bother cleaning that because that was just a nightmare. And I'm probably never going to replace this potentiometer again. Yeah, the traces aren't too hard to follow. I can actually download the trace. There's a picture, the silicon chip stencil of the traces online, so I can get that. I just can't get the actual schematic of the circuit, which is a shame. But I can work with this. And the reverse engineering is done. It actually took 2-3 afternoons, so really not too bad. And I didn't really look over all the the digital chips, so I'm not super familiar with the circuit, but it's okay because I can study that in my spare time. What I was really interested in was the output amplifier section, and that's where I've chosen to trace the issue from. And let me just show you what I found. Okay, so this wire that I showed you before, which had the nice sine wave on it, is actually the output of this amplifier right here, which I think is some kind of preamplifier. But this is the output of this, which is this silver thing right here. And that's all seemed to be fine. So I traced from there, because I know there mustn't be anything wrong with the digital stuff if there's a nice sine wave coming out. So I went over and I traced it all down, and it goes up into the front panel and all that. By the way, the front panel didn't actually have an online version of its PCB traces, so I had to look at those myself, but it wasn't too hard. I traced the issue back to either the output amplifier or this LMF 100ccN, which is a capacitive filter. Now, I am not sure which of them it is, just looking. I'm really hoping it is the output amplifier, because the LMF 100ccN is now obsolete and really hard to get. So if it is that, I'm not going to be very happy. So I'm really hoping it's a problem in this section, because it means I just have to replace either this, which is just TL071 equivalent, and all these two transistors here, which are not that hard either. But yeah, very annoying there. And I'll just show you some other waveforms. I noticed, where was it? Was that it? Nope, it was, yeah, this one. So pin 1 of the LMF 100ccN has this clipped sine wave on it. I'm not sure what that means. Let me just probe this other one. Yep, so that is on LPA. Not entirely sure what that means, if it's a clipped sine wave. That leads me to suspect that it might be a problem with the chip. But I'm just going to try and replace stuff in here first before I get to there, because I'm going to have to try and find one of these, and it's going to be expensive. I've fixed it. It turns out that there was a crap solder joint from this jumper, the bottom one, to the this pin of this potentiometer here. So I just reflowed the joint there, and now I can show you. So let me put this in, and there you go. I'm not sure why it's negatively biased, but I mean, I guess that's not really a problem. But yeah, there you go, and I can do a square wave just so you can see it's the same frequency. And yeah, so that all works, and this is the level control from 0 to whatever. Same for the square wave. It's a bit noisy when you change it, because what do you expect from a silicon chip kit from 1990? But that's pretty good, and we can get a 500 kilohertz. So let me change my time base here. Yep, all nice. Yeah, I don't know why it's biased like that. I think that's just an artifact of the circuit, but if I AC couple it, there you go. Done. Fantastic. Alright, so I guess that saves me having to risk desoldering one of these and then try to find one. So yeah, that was pretty good. Thank you guys for watching. Make sure you leave a like if you liked the video. And yeah, I think I might attach this what do you call it, reverse engineered thing online for anyone else having the same issue. And yeah, alright, see you guys.